Next it's time to open up Indigo, and any moment now. Okay, you want to take your time, do you? Thank you. Now here is the Indigo source project, which you can download on my website. It should be below the video name. Now what I'm going to do now is take you through each command line by line so that you can understand what's going on here. And then what you can do, you can download the project file, look at the code, play around with it, produce whatever you want to create, and as I've written here, you can use it for whatever purpose you need. Whether you can use it for casual purposes or commercial purposes, I don't mind. So to begin, I've disabled the escape key, so when you press escape, the program will not exit as soon as you hit the escape key. What I've done is I've taken over the escape process. You can exit the program by pressing escape, but I've overridden it, which you'll see further down. Here we have the global level state, which is a double integer. This is a double integer that will store various flags or options, the state of the level, and here we have the first 5. We've got 64 to play with because the double integer is a 64-bit variable, but so far we only have 5. We have the level loaded, ball released, start position set, hold position set, and ball is still. So if the ball is still, the 5th bit will be set to true. If the level is loaded, the 1st bit will be set to true. Further down we have our first user defined type. Let's get rid of this comment. Press save. Here we have a vec type, or a vector. It stores an x, y and z position, rotation, speed, or whatever you want to store. There are basic features, the vector 3 and the vector 4 index based variables that you could use. However, I've chosen to use a user defined type for speed, and I simply prefer to use UDTs for everything. And we have the view type further down, which stores direction, height and distance for the camera. So the camera will be able to move around and adjust its height and zoom in and out, and we'll be able to take a good look at the level. I've set the text size to 32 and I've chosen the Arial black font, which hopefully you have installed, otherwise you need to change the variable name. We have the start position, we have the old ball position, which is used to read the velocity of the ball. We read the velocity by comparing the distance between the position and the previous one. We have the hold position, which we'll retrieve from an object inside the 3D World Studio file. We've got the view itself, which stores the direction, distance and height, which you see has been defined by the UDT, the view type. We've got a global. We've created a vector 3. The only reason why I've used the vector 3 in this program is because the Dark Dynamics plugin requires the vector 3 to obtain the information I need from the ball. Here we have the course, which is going to be our level, a temporary object, the ball source or the source ball. This is the sphere that we will duplicate to create the balls. The ball itself is only ever one ball in question. However, we can change its value and treat whatever object we see fit as the current ball. Below here we have the ball material, which I've simply assigned a value of 3, which is the same as the source ball. So I've just indicated that these two should share the same ID. We'll see what the ball material is later on. Here we have the director, which is going to be a little triangle. It's going to indicate where we're facing. Now obviously we can see what direction we're facing, however it's nice to have a little extra hint as to where the ball is going to go. And perhaps if you wanted to, you could add an indicator that could show what the ball is going to do as it moves, with a little arrow pointing where it bounces and how it's affected by the gravity and perhaps wind. However, for the moment, we're going to stick with a little triangle which indicates where the ball is going to go, or its direction anyway. Here we have the director texture. Again, I've used the same ID for the same entity. Entity number 4 will have a texture which is called balldirector.png, which is supplied with the project files if you've downloaded it. We're going to make a plane for this object, and we're going to have it in really small size 2. You can make it whatever size you need for your environment. My environment is pretty small. We have it rotated 270 degrees so that it faces upwards. It becomes something that faces upwards, and we fixed its pivot here, which indicates to the engine that although I've rotated it 270 degrees, from this point onwards the rotation is 0 degrees. Therefore our plane is facing up when set at angle 0 on the x-axis. Now the set object transparency has been set to mode 2. We've disabled the Z depth. This means nothing will block the sight of our director. The ball will be shown underneath the director. Any walls or objects blocking the view of the director will not block the vision of this indicator, so that we can still see which way we're facing. And we've just applied the texture accordingly. Further down we have a timer stored, and we've taken the timer's value from this point, the start of the program. Now in this case the game starts immediately. However, in a real game you probably want to have a menu created before you start storing any game dependent variables. However, in this case we're storing the time, which is going to affect how much score you obtain, and also the shots, the number of shots, and this integer will store how many shots it has taken, or how many shots you've taken. Both the time and the amount of shots will affect how much score you will be able to obtain. And here we have the shot power, the shot direction, and shot height. Power is obviously going to affect the velocity of the ball. Direction is going to change its angle, and the height will affect its chip height, affecting how it bounces and how high you hit the ball over ramps or obstacles, if you like. The score, the best score, which currently isn't being used in this demonstration, however you can use it for whatever you need. Development mode will be used to change the mode of the game to enable me to explore. However, I'm not going to use this for the time being, but let's leave it there anyway for the future. Ball still loop count. Forever how long the ball remains still, we'll add 1 to this variable. When it reaches a certain amount, we will indicate that the ball is still. More on this later. And the velocity is something we're going to store, something we're going to use to store the velocity of the ball in motion after it's been hit by the player. The ball list. Now this requires a function called the free list, reserve free list, make free list. This is a function made available through the Matrix 1 utility plugin, which you can download on the TGC website. Here we have another function which requires the Matrix 1 utility plugin, make frequency ticker. This is a clock that's going to tick once every second. If I wanted it to tick twice every second, then I would change its value to 2, I believe. Let's have a look at the documentation. Press F1 with the cursor on top of the text, and the help documentation will load up. Let's see, what is the meaning of this parameter? Here it says It creates a timer that will tick at the instructed frequency. The frequency is specified as the number of ticks per second. It is valid to use fractional frequencies. For example, specifying 0.1 will provide a tick every 10 seconds. So here you see it's the number of ticks per second. Every time this ticks, we can do whatever function or call it whatever routine we want to call. Moving on, here we have the construction of the source ball, which has been facilitated through the use of the make object sphere. We have made the object size 4, and we've created 64 rows and 48 columns to make it nice and smooth. We've colored it a kind of bright yellowy color, extremely bright, and we've hidden the source ball because this isn't really going to be used directly. Synchronize on, refresh the screen at 60 times per second, change the background to a slight grey color, and another function which requires the Matrix 1 utility program. I didn't show you before, but we have a console active here which enables you to store information about what's happening in the program. We'll take a look at this later on. Dyne start. Now this is the Dark Dynamics initiation function required to initiate the Dark Dynamics physics plugin. And we have a few variables. The one that we're really interested in here is the bounce variable. We've set that to 0.5. I haven't set it as a global because I'm simply using it to pass to this function here, the make material function. We're making the ball material with these settings, and as you can see here, we set the bounce to 50% or 0.5. The static friction and dynamic friction will not have much effect because this is a ball. So for spheres, they roll. They don't really rub against things, they roll. And to slow down the ball, we're going to have another feature take care of that, which is the angular damping. Here we have the gravity set to 100. This can be changed to whatever you need. If you don't set this, the objects will not fall, so you need to set this at a negative value to cause the objects to fall. If you want to produce wind, you can add a few units on the X and the Y parameters. Load level. Let's take a look at what this does.